All right, so we'll get started with the workshop. So the workshop is set up partly with just sort of an overview and how things work and how things are put together. And then we'll actually run some stuff, right? So before we get started, so my whole reasoning for this was, when we take our classes, when you're in classes, we try to get you credits from Amazon or Google. They'll give you a limited number of credits for a semester to try out a few things. And mostly the credit is enough for running a virtual machine for the duration of your semester project or some such thing. But if you want to run anything more complicated than that, you're going to run out of credits very quickly. And then it's not cheap, right? So at one point I was like, well, can I take a whole bunch of computers, go on Craigslist and buy cheap computers and then set it up at home and build my own little cloud, right? So I've tried that, and that's a difficult project. And then over time, it was like, well, if we are learning, so this is just sort of this, this is not for production. This is for, I just want to build something to see how it works. Can we do it on a small computer, right? And so this is sort of a third, I would say, iteration of that process. So the first one I did was, at that point, we didn't really call it all these things, but it was pre-COVID. So that's the time frame of what we did, right? So how can you run a cloud on your laptop and do things with it? I remember for fun, I even did something like set up a cloud on my laptop, and then I had to travel someplace. So I'm on a plane, disconnected from the internet, right? Somewhere over Kansas. And I'm like, oh, look, I can run a cloud on a plane at 30,000 feet. In the air. So that was kind of exciting, nerdy, but exciting. And then, COVID happened and we did a whole bunch of things, and now we're sort of coming back from all of that. And things have progressed to a point where a lot of people want to see how to build things on a local machine or a local setup, maybe go to a lab like this one that we have here and, string up like 2 or 3 computers together and see if we can do something interesting. To give you a very quick anecdote, pre-COVID, when we tried to do some of these things, and this was many years ago now, we used to run iLearn here on campus, right? And iLearn ran on many servers. So there was a time when those servers were upgraded to a new set of servers. And I was like, so what are you going to do with the old servers? Oh, we're going to scrap it. So I said, okay, well, can you delay the scrapping by maybe a semester? And we'll take the old machines in that one semester, wipe it, and build our own little cloud. So we even did that. We ran OpenStack on, I think, 3 or 4 servers. And, for a project, it was great. It did what it was supposed to do. And then all the machines went to the grinder, recycled and done. So that's sort of the backstory of that, but this is something where I wouldn't say it's beginner stuff, but if it's done right, you can actually run this stuff on your own computer. So this workshop is also part of some of the other projects we're doing. I'll talk about that. So we have an initiative in the College of Business called the Lamb Larson set of initiatives, and this is what's called the ETI, or Emerging Technologies Initiative. So this is where we focus on new tech, things that are making, for instance, the AI revolution happen. Because AI doesn't run on thin air, it runs on the cloud. So that kind of stuff, and you can read more about it there. So it's a pretty interesting initiative. Give you a little brief intro about me. So I've been here, this is my 25th year. I've been here at State for a while. When I first got this job, I had no gray hair at all. I was like you guys. And now it's almost all is gray. I'm also department chair. This is my 3rd year. I've been running the department as department chair. And along the way, I've done a whole bunch of different things. So, on campus, we do teaching, research, and service through projects. So teaching-wise, I've taught, my favorite courses are in the area of networks and cybersecurity. That's what I've taught for the longest time. The first semester I came here in spring of 2000, I taught ISIS 565. Back then it was called, I think, BICS 565, right? And then I also teach in the graduate program, IT strategy type courses. And then, I've taught pretty much any and everything in information systems. Because, once you start working with things, they're all connected, You have to know how databases work. You have to know how networks work and so on. In terms of research, these are sort of 4 areas that I've done work in. My early years were with online learning. Before we had online learning, we used to call it computer-based learning. So how do people learn with multimedia on a PC and stuff like that? So I did a bunch of research, and iLearn was one of our big projects back then. So I was part of the team that piloted it. We had somebody here who actually wrote the very first book on Moodle, the software that ran iLearn, and we were credited in there. So did that for many years. Then I switched to content management. I did a lot of work in that space and worked with Drupal, which is what we use on our campus quite extensively now. I also served on the Drupal Association's board of directors for 6 years. I did a lot of work with free and open source software. A lot of my research is grounded in that. And we done a project called the Commons Initiative. And then the last phase I've done is with edge and fog computing, which is you're talking about cloud computing, but you want to do it here on the edge of the network, like in a lab or at home and stuff like that. So I did a lot of work with a project called One Laptop Per Child. So we were running networks in middle of nowhere. Like you would go off to a place and no electricity, no internet, but you have to run a network there. So that's quite the challenge. Other projects we've done on campus. So we've run civic tech and civic engagement hackathons for many years. So we have a site there you can check out. I did the One Laptop Per Child project in different countries and ran the San Francisco chapter up until pre-COVID or so. I think the most interesting country in this list is Tuba. First, you have to figure out where Tuba is. And then you'll find, if you go search for it, an association with Richard Feynman. And then you'll have to figure out what that association is. So some fun exercise for you. And then I also work with a nonprofit that started at SF State called Wired International. We do health information projects around the world. And so some countries that, I built systems that are implemented there. So that's sort of a blurb about me. And then, of course, on all the oodles of free time that I have, I like to do things that I liked as a kid, which is fix old electronics. So there's an Instagram site there. At the bottom, there's a link if you want to check it out. I just go find old analog gear, vacuum tubes, that kind of stuff, tape machines, and fix them. I think at heart, I'm basically a tinkerer, somebody who likes to build things. And so I love to take things apart, see how they work, put them back together, make it happen. So that's a little thing I do on the side when I have some free time. Everybody should have free time, right? Okay, so the title of this thing has some buzzwords. So let's first tackle those buzzwords because they're interesting, but they're there for a reason. So if you look at the PDF for this or the poster outside here, thanks to the Makerspace folks here, Chris is here. Thank you, Chris, for getting us that poster. Looks very sharp. One of many that we'll be running here. So there are 3 parts to this, right? There's the first line, it says orchestration with microclouds. So we should tackle that. Then there is cloud computing. We should tackle that. And then there is zero ops with Kubernetes. We should tackle that as well, right? So that at the end of this, these are not buzzwords. All right. So I broke it down into 3 parts. We'll begin with cloud computing because that's sort of the basis of a lot of these things, right? Unless you have a good understanding of what really is the core of cloud computing, all the other stuff is very hard to sort of assemble in your head. So cloud means a lot of different things to different people. But if you look sort of back to where things came from, there's Moore's law, which basically talks about how the ability of the processor essentially doubles every 18 to 24 months. And the size of the chip and the cost of production is essentially constant. So if you have more, if the ability of the processor keeps on doubling, arguably we should be able to do more with it. That's sort of the idea. So if you follow that curve, that's an exponential curve. There's Metcalfe's law, which basically says that the utility of any kind of a network is proportional to the number of nodes you add to it. So if I have a telephone network, every time I add another phone to that network, the utility doubles, right? So it's again, it's exponential. So at some point, if you put the 2 together, you basically end up with what we call cloud computing, because processors are cheap, networking is there, put the two together and run it someplace and you have cloud computing. That's kind of what gave it the impetus once we got to the end of the 90s, right? And that's where cloud computing began. So one way to look at it is that you can think of it as a service. And this is what we would call a utility perspective, which is think of gas or electricity, right? We don't quite know where electricity comes from, as in when you're at home, you plug your laptop or phone charger. We don't really stop and think like, was this solar? Was this hydroelectric? Was this nuclear? It's just there. It's a utility and you get a bill at the end of the month and you pay, right? Whether you like it or not, you have to pay. That's a utility. So people say, okay, I don't need to know how it works or where it was produced. I just need to use it and bill me for whatever I use. That's a utility perspective, right? So if you think of this, one way to look at cloud computing is, say, Google Docs. You open a browser, sign in. There is no software installation. The whole software comes through the browser. You simply use it, you save it, you sign off. And when you hit your 15 gigs, they'll come after you and they'll ask you to pay more, right? Pay as you go. So that would be called software as a service. And so there's a model that we often talk about that's listed here from a paper. If you took my network class, you would have gone through this. That little diagram you see there. Software as a service is at the top, which is you need to know next to nothing about the technology. Everything comes to you through the internet, right? Like Google Docs. Then you have a layer below it called platform as a service. And this is where you have some technical know-how. You're going to build applications with Python or Java or one of those things, and somebody needs to run it for you. So that's platform as a service. And then you have a layer below that, which is infrastructure as a service, which means I know how to write the software and I also know how to run the application and all of that stuff. I'll do all that in-house, but somebody run it for me. And that becomes infrastructure as a service, and so on and so forth. You see, and then at the very bottom, in fact, there's a layer called hardware as a service. Companies will give you a blank server and you install everything on it, right? So we sort of have to pick. And so a lot of things that we want to do today are in that layer called infrastructure as a service, as in, can I build an infrastructure on which I can float whatever I want, right? Okay, with me so far? All right, and then I see we got some folks online, so all right. So it's utility oriented, you pay as you go. Some of the challenges with this would be, how small should I start? And if my business grows, how do I scale up, right? So if, for instance, if you build an application, e-commerce application for a small company, and then you grow, how do you then scale up? You can't simply say, give me a bigger database. Then you have to say, give me a second database, and how do I manage the two together, right? Or how do I do a failover so that if my web server is failing, it switches over to a second one and so on. So that is essentially a challenge of scaling up, and you need something that can help you grow this thing as your business grows. And so that's where the second concept comes in, called orchestration, which is, how do I take all the engineering stuff, but make it work together as it grows up, right? So as it scales up. So can I go from a server that has one CPU to two CPUs? And will I have to interrupt service for that, right? If I interrupt service, my business goes down. What if I have to add a second hard drive or grow the hard drive from 1 terabyte to 5 terabytes? How am I going to do that? So these are some of the challenges where you need everything to be sort of, running in orchestration and be able to scale those things up. So in orchestration, what we see is the vendors out there, so Amazon, Microsoft, Google, and so on, they will streamline the process. So it's relatively easy for you to go in and start something. And then what you can do is you can say, okay, well, now that I'm starting this, how can I increase, the number of processors or RAM and so on the fly? So most orchestration platforms are what we call API driven, as in you don't build for a specific vendor. You don't build for Amazon. You don't build for Google. You build using a model, and then the orchestration software will implement it on Amazon, right? So I'll give you an example. Let's say we take the example of iLearn, which used to run here. It still runs here. I think it's till the end of the academic year or so.
Yeah. They've
Or maybe
switched
into
mostly over, but I
Yeah.
think they're still running.
Yeah. So let's take the example of iLearn, right? It runs on a database, web server, and I want to run it on Amazon. Orchestration would be that we set it up as iLearn, and then we connect it to Amazon, and it runs on Amazon. And then tomorrow, if Google comes and says, we'll give you a better deal, better pricing, I should be able to switch that over to Google and not have to rebuild for Google, right? So it's a way where you basically take a model and then you can abstract it and implement it on any cloud provider. And that's difficult to do because in many cases, of course, the vendor doesn't want you to leave, right? We want you to be locked in, come in, build with us, and then never leave. But if you do something like this, you have the ability to switch cloud providers. So orchestration is quite interesting there. So we'll be using something called Ubuntu Juju to do some orchestration. I'll show you some examples here. They have a system called Charms. And since we are here, we can quickly jump to the web and see what that looks like. So they have a website called Charm Hub. And this is where you have all kinds of these models, right? So for instance, if we look at databases, let me check the databases here. And you can see in databases, there's MongoDB, there is MySQL. So these are all, pre-built models. And I can say, hey, take this MongoDB and using an API, run it on Amazon. Take this MongoDB and run it on GCP, Google Cloud, right? So this is something that Ubuntu runs. So we'll come to this in a bit, but this is one of the components we'll look at. And the way it works is that it is agnostic to the cloud provider, right? So you can see that you have Charm Hub, which has all the models for the software. And then you use the API, so connect to Amazon or Google or Cloud or even Kubernetes for that matter, right? It doesn't matter. And then Juju basically then tells the backend how to install all this. It's near magical when you kind of run with it. Okay, so here's an example. Like if you wanted to install HBase, which is Hadoop HBase for big data stuff from back in the day, you could pick your cloud and the model would basically run on 8 computers. If you did this by hand, you would have to go to each computer and basically install one component at a time. So that's time consuming. And then you would have to configure them to sort of talk to each other in a certain way. So here's an example of what it looks like. If you have to install HBase, you would have to work with something like this. You have a client, you have a regional server, you have something called Zookeeper, and then you have a file system, and they all have to be installed and configured, and they all have to talk to each other, right? It's a fair bit of work. Instead, and then you could do all your distributed crunching. Instead, if you were to use this Juju Charm business, there's the architecture. You can see it's got the Hadoop client, it's got the rsyslog, it's got Zookeeper, and so on. If you had to implement this using Juju, it's literally as easy as that one line that you see here, Juju deploy HBase. That would be the command you would issue. And Juju basically does all the heavy lifting of reaching out to Amazon or Google and spinning up machines, installing whatever is needed based on this map, connecting them, configuring them. And it'll take a few minutes, but you will actually have an 8-machine cluster running for you doing what HBase is supposed to do. So those of us who have done this for a long time, Chris, I know you've done this before, it takes forever to set up stuff. You set up a database and you go in there, you edit the config file, and then you grab a password here, you go over there, all kinds of things. This is all automated. And the reason for this is that with orchestration, if it is something that repeats, then you want it to be automated because you don't want a human sitting there typing away stuff, right? It should be automatic. So that's one of the things we'll be using. Then the other is, cloud basically runs on virtual machines. So we always talk about VMs. And depending on your computer, whether it is Windows or Mac and so on, you would use different software for it. So VirtualBox, VMware, and such. So that's sort of the traditional way to build a virtual machine. And it's still quite useful. But there is a variation on the concept called containers. And containers are slightly different. So Docker is a container that a lot of people are familiar with. You may have used in some of your classes, perhaps. What a container does is it basically takes a certain area of your file system and closes it into a self-contained space, right? So think of it as like if you were to go on your computer, let's say on Windows, you go to C:, right? And then you go under My Documents. Let's say there's a folder called Samir. I could create a container that only encapsulates the folder called Samir. And whatever I run in that container has no knowledge that anything else exists in the file system, right? So you can actually create little containers all across your system. And the beauty of containers is that when you create a container, by design, it cannot speak to another container on your laptop, as in they're separated completely. And then you get to design that if you want them to interact, what can be sent across? Is it a one-way connection? Is it a two-way connection between containers? So it's an old concept. Back in the day on BSD Unix, we had something called BSD jails. On Linux, there was chroot, which is change root, and then Docker came along and so on. But I saw an interesting parallel with mobile phones, right? So if you think about a mobile phone platform like Android or iOS, notice that when you install an app, it'll take X number of seconds to download the app and then install it. When it's time to uninstall the app, the uninstall happens really, really fast, right? You go and say uninstall, and it's gone. And the reason for that is that mobile platforms actually run apps in containers. So the entire app basically lives in its own contained space. And when you say uninstall, it literally deletes that container. It's all gone. So a lot of the work in the mobile space actually fed into the creation of containers. And they're great because they're secure, as in, you can have 10 containers, 20 containers on your computer, and they're all sort of secure. In some cases, there are issues with, like for instance, on some of the versions of Ubuntu Linux, you would have Firefox running in a container, which is great because it contains the web browser. But startup time may be a little slow and so on because it has to do a whole bunch of things. So what we found is that in cloud stuff, containers are actually quite fast and economical because they reuse a lot of resources. So if you want to do things very quickly, rather than spinning up an entire VM, you basically just run a container. So that'll sort of become the default choice in many cases. Now, there is a situation where you want the opposite, which is you want to run an application, say a database, but you want the database to run across two computers, right? So the initial situation with containers was, I want to run many databases in many containers on one computer. But if you flip the situation, you would say, I want to run one database across two computers. So let's say I have two laptops on a network. How do I run the same database? So not two databases, but one database spanning both computers. And a few years ago, I would have said that's impossible. But there is a newer concept, which is what we're coming to, called a pod. A pod can actually exist across multiple computers. So I can actually have two laptops running one pod and then say, run a database in this pod and let the computer and the network sort all that stuff out as to how that database will run in both locations, right? To me, it'll look like one database. So pod is sort of the new currency, if you will, for a lot of these things, which brings us to this item, Kubernetes. So this is a project created at Google for the purpose of this. But basically, they run with the unit of pod. A pod can run an application. A pod can run a group of applications. A pod can be on one computer. A pod can be on multiple computers. So it makes it very flexible, right? But now it adds a burden on you to design it. Because, how am I going to design one pod that runs across three computers? Can I run a pod across a Windows laptop and on a Mac M2? Two different architectures, right? Those kinds of things. So Kubernetes is not easy, but the point of this workshop is that if you start off with something simpler, and see how it works, then you can scale up and do something more complex, right? So, so that we'll look at that. And now the third part to this is called zero ops. So that was in the poster. So what is the zero ops thing? Part of it is marketing, but hey, we're in a business school, so that flies, right? But there is some expectation in zero ops that a lot of the things should be automated, right? So in zero ops, what's happening is, you may have heard of the term DevOps in one of your courses. DevOps is basically you take the development cycle and the operation cycle and make it into one continuous thing. In the early days, like when I was a student, development and operations were entirely different. After we did development, we would give it to operations, they would run it, then they would come back and yell at us saying we did it wrong. Then it would take us 3 months to fix it, and then we give it back to ops, and that's why it took 3 to 5 years to build things. Now, everything is in a continuous loop. You do development, you test it, you push it out to operations, then they come back and say, tiny fix, and you can fix it, and you have this continuous loop so you have a term like CI/CD, continuous integration, continuous development. So zero ops is basically saying, let's do DevOps, but a large part of that should be automated. And take the human out of the picture, make it automated. Humans still sort of oversee things, but they don't actually do a lot of the detailed work. The heavy lifting is done by automation. Therefore, zero ops, you can say, is DevOps, but with very reduced dependencies on human intervention. So that's sort of the third component of what we'll be looking at. Then there is another part to this, which is this concept of planes. So if you took a networks class, you would have come across the layered model, right? The OSI 7-layer model, or the TCP/IP layered model, and so on. This is similar, so that's why you can see some analogies. But basically, the idea here is that what they call a management plane is where humans are giving specific commands to the cloud, right? By typing like a one-line command or clicking a button or so on. The control plane is where all the network logic is done. So any kind of routing, IP tables, all of that stuff is in the control plane. Data plane is where the actual data runs back and forth. So in terms of the layers, you can think of the management plane as the application layer at the very top, right? And the data plane is at the bottom at the physical layer. And then the control plane is somewhere in the middle. So I tried mapping this, and it's sort of like this. This is your 7-layer model, right? Management, control, data, and this was sort of how it would map to the different layers of the model, right? Not exact, but in terms of expectations, that's sort of what it is. So when they build things, they will basically say, okay, this setting will be in the data plane, this will be in the control plane, this will be in the management plane. So I'll show you some of those things in a few minutes. Okay. So now comes Kubernetes, but hey, I want to run this on my laptop. So there is a version of Kubernetes called micro Kubernetes. And it is spelled as micro K8S, where the word Kubernetes has 10 characters. So the first is K, the last is S. You shrink it down with 8 in the middle. So you get K8S, and it's usually pronounced as micro-K8s. So micro-K8s is a proper Kubernetes version. So it's not like a, like an emulation or anything, except that it is built for edge devices. So their claim is that if you wanted to run Kubernetes on a Raspberry Pi or a laptop or the computer in your television, right? I mean, imagine you running a network at home with all the devices talking to each other. There you go. Why not have a Kubernetes network where your fridge can talk to your TV, can talk to your phone, can talk to your media player, can talk to your car, can talk to your cameras and all that? Why not, right? So you can have micro Kubernetes at home. So that's kind of where it comes from. And when I look at projects, one of the things I like to do is make sure that it runs on all kinds of things. So this stuff will run on Windows, will run on Mac, and will run on Linux. So depending on what you have, you can try it out. It is based on the real Kubernetes. So once you learn micro Kubernetes or micro-K8s, you can extend it to the real deal on any of these platforms. Okay, so demo time. So here, what I want to do is run micro-K8s as a cloud, and then use Juju to tell it to do things, right? The term juju comes from magic, right? So I sit there and I give it a command and it should be able to go and make that run. And the microcase cloud will run here on my laptop. So this laptop has 16 gigs of RAM, so not stellar. It's running Zoom, so we'll see how it does. And it's supposed to run all of this stuff right here. So fingers crossed, I hope it doesn't crash, but we'll make it happen. So first thing I'm going to do is set up a virtual machine so that I can install these things and run it. And then that's the point where we have a choice. So in your courses, you would typically use VMware, although recently because of Broadcom's acquisition of VMware, a lot of their products have been shelved. So I don't know what the status is of what you can and cannot get for free or a student license. VirtualBox is open source, so that's another choice you can use. On a Mac, you can use Parallels. You can use QEMU. And then on Windows, you can use Microsoft's Hyper-V, which is built into Windows. So you have multiple choices. And for a project like this, it actually doesn't matter. You can run any of those virtualization things as long as you're able to run a virtual machine. The other choice is something called multipass, which is what I've been using. The difference between the two is VirtualBox is visual. You can see a lot of stuff like click next, and fill in the forms and all that stuff. Multipass is all command line based. But the difference is with multipass runs on Windows, Linux, and Mac. Once it is set up, it probably takes me 20 seconds, maybe 30 seconds to set up a virtual machine. It's that fast. And then once I'm done with it and I'm done playing with it and I don't want it, I can destroy it, like wipe it clean, set up another one. So for development work, it's really fast. But if you want to learn, I would say pick something like VirtualBox because it's easy to manage, and then set up a VM. Kevin, who's here, has set up a bunch of guides. So you see a link there. We'll send that link out after the recording as well. So Kevin's guides are all there. Kevin, so these are all things to set up virtual machines, right? On different. So let me actually pull this up while we are here. So Kevin is a student of ours doing his independent study with me, ISO 699. So here are the guides. So how to install Windows subsystem for Linux. That's very useful. How to install Git, Postgres, Hyper-V, VirtualBox. There's a demo of Mattermost that he's working on.
You can sort by name, and they'll have it. That list not that place, not in numbers.
Oh, but by this here? Oh, okay. Oh, I see you have numbers on there, right? Yeah. Okay. So, and you began at 0, which is very telling, as it should be. So flowchart to install Mattermost. Then you have Hyper-V, you have Windows subsystem, Git, Docker, Postgres, VMware, and Oracle VirtualBox. So these are all very handy, and we'll post the link, and then these slides will be in the box as well for us. So thank you, Kevin, for doing that. And as we come up with more things, we'll just maybe add it to that folder. Okay, so for this workshop, I was like, should I do VirtualBox? Should I do multipass? And I've been, fiddling with this at home. My home network is pretty well established, and I run it, right? Thanks to our friends at Sonic, who provide me with a 10 gigabit synchronous up and down fiber link. I don't even have anything at home that does 10 gigs, so I can't even test it. The most I can go is 1 gig, but I have full control of my network. The problem is if you're at SF State, we have hardly any control of this network, right? So if I'm on Wi-Fi right now, my IP address will be 10.143. something, and all kinds of things are shut down and closed, and you can't do this. So I wasn't quite sure how this will work, but we'll see. So multipass is one option, but I also have VirtualBox. So I figured I'll do both, right? I'll do a quick run through with multipass, show you how that works, because you'll see how fast it is, at least at spinning up a VM. And VirtualBox, I have more control on our network, so we'll try that. All right, so should we switch gears and step into that? Actually, I didn't even stop to ask you guys if you have any questions about any of this stuff, anything I can help elaborate on. I've just sort of been going through the slides. Questions? Well, let me ask you, does this make sense? if you haven't done this before, yeah?
Yeah.
Okay. So, because I think that, for me, I guess as a teacher, that's one of those things. There's the default mode of a teacher. So when I'm learning stuff myself, I'm always thinking, if I had to teach this, how would I teach it, right?
Actually, with the pods, how does it load balance between?
That's the magic of Kubernetes. So I'll show you a little bit of the stuff if we can do it here. But for instance, if I set up everything on VirtualBox here, arguably, if I had a network here, like a Ethernet-based network, I could bring in a Mac Mini or I could bring in a Raspberry Pi and load balance across those and say, oh, extend my pod from here to the Raspberry Pi. Raspberry Pi doesn't have much processing, but for whatever reason, or a Mac Mini, for instance. And the software takes care of all of that stuff. And the best part of all this stuff is this is not brand new. Kubernetes has been around for a while. All the cloud mumbo jumbo that we deal with, all the AI stuff, everything runs on this. In fact, there's a great example of using microK8s on Lenovo servers. I think 4 servers, where 3 servers are loaded with GPUs, NVIDIA GPUs. And you basically use microK8s to provision all the stuff, and then you can run, I think it's TensorFlow, to do the AI stuff, like image recognition and stuff like that, using 4 servers, and everything is managed by this. That's a little too complicated for a demo, so, but I have my eyes on it. So maybe over the summer, I'll sit and fiddle with it, get some computers strung up together and run it. Okay, so let's see how this will work. So multipass, like I said, runs on all 3 platforms. So Windows, Mac, and Linux. Somebody, okay. Like I said, it's got a very fast start time. So if I had to do multipass, what I did was I did some descriptions of it. So in my case, I have this Dell laptop that you're watching the Zoom on. It runs Ubuntu. So that's the outer blue box here. I would install and run multipass, which would give me this green Ubuntu virtual machine. And inside of that, I would install microK8s. And there I would use Juju to set up WordPress with a MySQL database. So sounds complicated, but those are the layers, right? So multipass is all, well, mostly command line based. So I would essentially run these, and I'll show you what this means, and I'll run it in a minute. So you can see the line in the middle here. It says, first I would install it. So we use something called snap to install in Linux. So I would install it. And then I would launch a name of the virtual machine. I'll call it tutorial VM. And I'm saying that the RAM we want here is 8 gigs. The CPU we want here are 2. So like if there are 8 cores, I'm using 2 cores. Disk, I want 20 gigs. And the release of Ubuntu that I'm using here is called Jammy. I could use some other release as well, right? So let me run this and show you how this works. So I'm going to open up a terminal so you can see what we can do here. And I'll kind of replicate this as we go along. So, and I'm on Ubuntu Linux, so that's where we'll start with. So that's this sudo snap install multipass, right? So if I run this and give it my password, it'll go and grab the version of multipass from the backend using the snap system. And there are hundreds of snaps that you can install using this process. But in this case, there you go. So even before I could finish my sentence, multipass is installed. Now, huh?
I started mine early. It took me about 2 minutes.
2 minutes. Okay. So now I would do multipass launch -n, and we'll give it a name. So it's tutorial VM, right? And you can give it any name you want. I want a memory of 8 gigs, so lowercase g. I want 2 CPUs, CPU cores. I want a drive of 20 gig, uppercase G, right? And then I'm going to use the distribution version called Jammy. Ubuntu uses these names, Focal, Jammy, and a whole bunch of other names. So that's what they use here. So I'll say Jammy, right? if I do this, let's see what it does. So it says it's creating a tutorial VM, retrieving the image. So this is the image that it is getting from Ubuntu's cloud services backend, where they have these ready to go images. So this will take us, a few, maybe like a minute or so, because it's retrieving the actual image. These images are pre-built for doing all kinds of enterprise grade stuff. So it's not something where it's just for a, classroom exercise type thing. This is the real deal. So we'll give it a few seconds and it'll pull that in, and then I'll show you what the VM looks like. While this is running, if you use Windows or Mac, you're typically used to a graphical user interface for a whole bunch of things, unless you go to terminal or PowerShell. In Linux, almost everybody's just used to using the terminal. So in many cases, if you have this, this fear of the terminal, you'll have to get over it if you want to do this stuff. Because so much of the stuff in the Linux world is all terminal based, right? So it's almost there. There we go. It'll verify the image to make sure we got all the bits, and then it'll start installing based on the configuration I gave it. So once this is done, I'll have a VM called tutorial VM with 8 gigs of RAM reserved for us, and a 20 gig hard drive reserved for us, and 2 CPU cores. I think this machine has 8 CPU cores, so it'll reserve 2. Starting tutorial VM. Okay, so almost there. It's initializing the things, and then once this is done, then we can actually run the third line there where it says multipass shell tutorial VM. Basically, it logs you into the VM once it is set up. It's a wee bit slower right now, and I wonder if it's because we have a live Zoom session running in the back. So maybe it's contending for some resources. Okay, so it says it's done. And I can quickly check. So multipass list. And there it is, tutorial VM. It's running. It has its own IP address and all of that stuff. So if I want to log into this, I would do multipass shell tutorial VM, as in switch to the shell of that. So once I do this, you'll see I'm now logged into Ubuntu at tutorial VM. So I'm no longer on the terminal of my laptop. I'm actually in the virtual machine. And now I can basically run this as a VM that I can build on, right? So the alternative is you use VirtualBox, and if you've used it before, you would be familiar with it. But I basically ran one. I used an ISO from ubuntu.com. I set up, so it's 20 gig drive, just like the other one, 8 gigs of RAM, just like the other one. And this version actually is not just the command line based thing, but it actually has the entire desktop. And you'll see in a few minutes why that's important for the demo. So in this case, when I run this thing, I'm going to actually get an entire Ubuntu desktop, right? And I would recommend that if you're going to try this, try the VirtualBox version because it's more friendly, if you will. But we'll come to this. Okay. Now, regardless of what method you use to build your virtual machine, once you have a virtual machine, everything from here on is essentially the same because you're literally running inside the VM and not outside on your Mac or Windows laptop. So this is the setup we have. I've got my laptop running Linux, but yours may be Windows or Mac. And we have some kind of a virtual hypervisor, which has given us the green box, which is the Ubuntu VM. So this green box is basically this terminal here. That's what I have, right? You with me so far? Yes. Okay, so next step, I'm going to install micro-K8s, which is the Kubernetes thing. So these are the commands, and again, I've tried to explain it. So the first line is to install it. You have to be sure to use the -- classic for this one. Then you change the settings for the user. So there are a couple of lines there. And then at the end, you install. The last line here is that you enable something called host path storage, which is for storage, dashboard, and DNS. So let me do these here. So I would go here and say sudo snap install microcates -- classic. A quick note here, Kevin and I were talking about this earlier when we were trying to do this a few days ago. There are two versions to microcates. The classic one is more friendly for learning because it is not so stringent. There's another version called strict. And the strict one is for, I guess, production use, at least to some extent, because it is very, very strict in terms of what goes in and out. So
It's locked in. Yeah.
it's very locked down. So for the demo, classic is the one that works. So let's hit that, and then you'll see it's going to go out and grab something and install. It'll take a few seconds. And get this, at the end of this, when this little download thing will be done, we will actually have a micro Kubernetes system running inside of this VM. So for an old timer like me, who's had to do everything by hand, and I know Chris remembers this, this is magic. I mean, this is magic, right? Because like you type one command and it all comes together. When I was a grad student, I would spend hours. I started learning Linux in 1996. I would stay up till 3 a.m. compiling kernels on a Pentium laptop. Take 4 hours to compile a kernel. Everything was by hand. So this is magic. There it is. We actually have Kubernetes running here. I'll do the other commands here. So we'll do the user mod one. So let's see, sudo user mod -lowercase a uppercase G. It's Ubuntu. So what we're doing here is basically saying, change the user mode so that I don't have to keep using sudo command, which is to go admin. I can just run the microcates commands just using the Ubuntu account. So to do that, that was simple enough. Next, we'll do permission stuff. So we'll do sudo chown. So change owner -lowercase f uppercase R for recursive Ubuntu, and then ~.kube, which is where the settings are. So let's verify there. I got one wrong here, chown, right? And I never learned how to type without seeing. Okay, so that changes the ownership. Then we do the third one, which is new group microcates. We do the third line, and then we'll do the fourth one, which is basically enabling some modules for microcates. So my CROK8S, enable, we want to do host path storage, path-storage, DNS, and dashboard. And so it'll grab whatever it needs and basically install all those things here. So, and this is just for the purpose of the demo to kind of show what I would do if I had to set this up on multipath. So I can continue with this, but I also want to run this on VirtualBox. So this is another set of commands I would have to do, which is to install the Juju, so it can kind of talk to all the stuff, and then finally be able to set up WordPress. So those are the commands there. So instead, what I'll do is I'll go back to the beginning here, right? And rather than running multipass, so let me turn off multipass. So we'll say Control D to exit, and multipass. So we have the VM. I'm going to turn this VM off so I can free up resources. So multipass stop tutorial VM. So we'll stop the VM. I'll switch to VirtualBox because there I have a graphical interface and I can show you how to set up the stuff. So we'll give it a there. So now it has stopped. That means it's not taking up any resources. We can close this for now. Let's go to VirtualBox. So last night, what I did was I grabbed a copy of Ubuntu and I installed it. So this is a blank install of Ubuntu. I haven't done any configuration or anything. So this is the one. This is sort of the second part of our workshop, which is we'll walk through and set up this thing and see how it works. I don't know if you folks want to try this or follow along. How do we want to do this?
You're blazing through it. I'm still downloading the image.
Oh, the ISO?
Retrieving image.
Oh, okay. Well, so we can wait for a few seconds and or you know, Well, let's see, it's 1:30. We have an hour to finish up.
You need to go a little later.
Yeah. Okay. Let me maybe run through this so that it's done. I can stop the recording and then we can set up wherever you are along the process. You know, if he wants to set up, we can do that as well. Okay, so it's booting up. Let me log in. So I have a VM inside, so Ubuntu inside Ubuntu, in a sense, because the host and the guest are both the same in this case, but you could as well run this in Windows. Are you running this in Windows or are you running it in
I'm running Ubuntu.
Ubuntu? Oh, so just like mine, okay. So you're not doing a VM inside the thing, right? You're just running it natively.
Yeah,
Okay.
like on my
Okay. All right. So this is the, I think this is 22.04 version from their site. I just grabbed the ISO and set this up. So there it is. So I'll do the same thing. I'll go into the terminal and basically do what I did for multipass, but do it in here. So we'll say sudo snap install micro my CROK8S classic. So I'm installing microkits inside of this thing here. So this will take a few seconds to install. So the process is pretty much the same regardless of how you start. You know, when I was looking at these, I was also exploring how would you do this on, for instance, Microsoft Azure, because you know Microsoft's operating system is Windows. Well, guess what? Once you get to Azure and you actually get to an account and set up these things, none of this stuff happens in Windows for Microsoft. It actually happens in Linux. So you're running a Linux VM on Azure to make this happen because none of the other platforms have the maturity needed to run any of this. Mac OS, forget it. They won't even give you the image to run in a VM. So in fact, I think from what I recall, on AWS, on Amazon, if you go and choose a Mac account, like if you want a Mac VM cloud image, there is no VM. It literally goes to a complete Mac mini. So they have a data center or whatever, where they have shelves and shelves of Mac minis. And they're expensive. And when you sign up, you basically get connected to a full machine, not a VM. So there's no VM for Mac OS there.
Not really
Exactly. And then for Windows, there is, again, very little other than getting the desktop. So all the Kubernetes stuff, even if it's on Azure, you end up basically running a Linux VM there. And all the other stuff is basically Linux-based.
What I found interesting when I was building the VMs on Windows was that I still have to install a subsystem for Linux, and you're still doing Linux on
Windows.
Yes.
Correct, right? Because you know, I mean, it's not that technically they can't do it. It's just that the software maturity is simply not there. The level of complexity and accuracy you have in the Linux kernel for networking, for instance, is unmatched. So none of those systems will give you any of those things, at least not at this point. So that's what they have to do. Okay, so we did that. Let's go back to our set of, where were we? Oh, I got to do this back and forth now. Okay, so we install that. We'll do sudo usermod ag -a-g. And in this case, because my account is SVerma and not Ubuntu, I'm going to have to give permissions to that account, right? So you see like here how we said sudo usermod Ubuntu account. In this case, it will be for SVerma. So we do that. So the SVerma account has permissions. And now we'll do the same thing for the other one, which is change ownership -f-r. Was a chown -f-r. I should have these listed somewhere. SVerma for tilde AUB. So we want to change the ownership there. All right. And then create a new group for microK8s. So new group. Okay, so there's that. And then I'll install the module. So microK8s enable. What was it? Host path, storage, DNS, and dashboard. So these are 3 modules that are needed for doing this. Okay, so this is one part done, which is it basically has what was that? Do not enable. Oh, some warning, but it'll get through. So my cloud backend is basically up and running, and I should be able to look at the status. We'll run status and see what we get. So let me go full screen on this. Okay, so if I do microK8s status, it'll tell me what's running. And since it just installed, it may take a few seconds. So there we go. It says it's running. So we can see it says that it's running right there, right? High availability is no. So high availability is like, unless you have 3 computers running this thing, so across 3 nodes, it's considered, it's not considered high availability. As soon as you add 2 others, it will switch to high availability. And everything else is there, and all these add-ons are enabled. It's got a bunch of others that I don't need right now. So we get this, right? Now we switch over to installing the software that will go inside using Juju. So I got a list of these. So I'm going to do the same thing, which is snap install. And again, I'm using classic. And in this case, we have to specify a channel, which is 2.9. So we'll do this. So let me clear the screen here so it's all out. So sudo snap install Juju, and we want the classic version, and then we want the channel, oops, CHANNEL to be 2.9. So that's a specific version. What I found was that trying other versions for this demo wouldn't, well, it would break some stuff. So I'm sticking to this because they've made a few changes. So I do this, and it'll go and grab Juju. This takes a little longer than the other one. But again, what can I say? It's magic. It just grabs whatever is needed and it installs it. Okay. So at this point, once we are done with this, let me go back to the slides, kind of show you visually where we'll be. We'll be here with this orange box, microK8s, right? And the Juju thing installed. And from here on, all we're basically saying is telling Juju to install the WordPress application, and then telling Juju to install the database. And then it will sort of take care of installing all of those things. So we'll go back here. Let's see where we are. It's still installing. We'll give it a few seconds. I suppose some of this can also be automated, as in, you know, this is a learning exercise, so I've got these commands one after the other, but there's nothing preventing you from grabbing all those commands, throwing it into a script, and just run that one script, and it'll do all of the stuff for you, right? Of course, in that case, there is no learning because you're not doing it one at a time to kind of see how it works. But once you learn how this works, to do all the things that I'm doing right now, it could literally be one shell script that can run all of it. My only concern is I may run out of RAM. Because Zoom's running in the back, right? And it's recording. So okay, we'll see. We'll see how far we get. Hopefully the next laptop I get from SFSU will have more memory than what we have here. And you know, that's interesting because the general use case is you go to the classroom, you plug in your laptop and you pull up a website and you run some slides and that stuff, right? It's the classic Chromebook example. Mm-hmm. Chromebook would be great for stuff like that, right? The problem here is that for us, the stuff we do, I need heavy lifting here.
Actually, most of things students are doing, even if it's not, you know, like at this level, won't be supported in Chromebook. That's why.
No,
Like multiple times when they've offered, they said, oh, we have this offer to get all these Chromebooks.
Mhm.
Said, no, thank
no,
you.
no. Those Chromebooks, I know the school district here, the San Francisco School District uses Chromebooks, but then the whole district has a contract with Google. So everything they do is in Google Classroom and Google Storage and everything is Google. So Chromebooks work great. Our infrastructure is all Microsoft. So Microsoft will have to come up with their own version of, what do they call that? Surface, like a Chromebook type thing, but Surface. And then that would work for us, I suppose, but.
I think they're nice, the Surface Pros, the little tablet version, because
Yeah.
they got Surface
Yeah.
laptops, they have the Surface Pros,
Mhm.
they're the tablet versions, and
Right.
they're very nice.
Right. So, okay, so this is still running, but we'll give it a few seconds. It's almost there. So after this is done, we should be able to look at our Kubernetes dashboard to actually see how things are set up. So we'll take a look. Let me see how much memory is being used from the outside while we're doing this. So there's my htop command. So you can see there are 8 processors. Number 3 is at 100%. So my guess is that that processor is dedicated to the VM, because sitting at 100%. Memory is, out of 15 gigs, 9.68 is being used. So nothing on swap. So it's really a CPU starvation thing at this point, I suppose, because it bounces between number 3 and number 7. So maybe 3 and 7 are dedicated to the VM. You can also see, like in the list here, VirtualBox is up top here, but rest of it is all Zoom meeting. So Zoom is eating up a lot of stuff. Sit out of here. Okay, we'll wait. Okay, oh, we're done. So now I've got the micro Kubernetes installed. I have the Juju orchestration platform installed. So what is Juju able to see on the backend as a cloud backend? So you do Juju clouds command, and it'll come back and say, these are the things I can see. So it says, here's our cloud backend. See that? Micro-K8's running on localhost, meaning here, and it's a built-in Kubernetes cluster. So we do have a backend that is recognizable now as a Kubernetes backend, right? We can, well, let me go through the install and then I'll come back and pull up the dashboard. So what we do now is we basically create an environment to set up our WordPress. So we do what's called a bootstrap. So Juju bootstrap, and we'll give it a name. WordPress controller, right? So controller is something that is used to create the entire model and then house the applications. And unknown cloud, I have to say Juju, where am I running this? Let's see. Juju bootstrap micro. So I have to specify which cloud I'm going to run this on. So I'm going to run this on the Micro-K8's backend and there. So it'll do a few things, and essentially it creates the controller is sort of a placeholder, like a space, and then you define everything inside the controller. So it'll do a few things, and it should be done pretty soon. So after this is done, we'll start to define our model. So think of the model as here is WordPress and here is MySQL, and MySQL acts as a database for WordPress, right? Downloading some images, okay. So it would be this picture here while it is downloading. Let me pull up this picture here. We are here. So basically we are using Juju to say, use the Micro-K8's, the one in light yellow here, backend to create that space. So that's the controller space. And now we'll create a model for these two things. And then we'll say in that model, install WordPress, install MySQL. one after the other. And then the last piece will be that arrow in the middle, connect the two together in a relationship. So we're getting there here. All right, almost done. And this is where you'll also see, so you have to have a fairly good grasp on IP address stuff. If you don't, I would recommend at least go look up some videos on public IP versus private IP space and network address translation, because you'll often come across IP addresses that begin with 10, so 10 dot, which is a private IP space. So this software uses extensive use of private IPs. SFSU also does. So our Wi-Fi is on 10.143. This is running on 10.152. So it's creating something internally. It uses a lot of these 10 dot addresses. So it's important to understand how this stuff works. All right, so we got that. So we're going to add a model. So Juju, add model, and we want a model for WordPress. And this is just a name I'm giving it, WordPress model. So it creates a model for these two. And now I'm going to deploy the actual applications inside of this, right? So just to keep parity with our thing. So we created the model here, and now we're going to deploy the actual charm. So remember I was showing you that charm hub list where it had all these different projects. A charm is basically a recipe for installation for an application. So WordPress K8s is what we want to install. So I would say Juju deploy WordPress K8s or K8s. Now, if you install WordPress in the past or install Drupal or one of those things, it's not trivial, but this one command will actually go and grab WordPress and install it inside of that micro-K8s cloud. So just give it a few seconds and see what it does. It'll go out there, validate whatever it needs to, and then locate the charm, which is the definition. Oh, it's actually already done. Okay. So let me do the same thing, but now for MySQL. MySQL, K8s, which is the Kubernetes version. So this will grab the MySQL database and also install it. So once this command is done, we will be in this picture with these WordPress bubble and MySQL bubble, but no arrow in between because we haven't connected the two as yet. And that's coming next, right? So this will, again, wait for a few seconds. So you get a sense of this concept of orchestration and the zero ops, like all that complexity. And again, I'll just say this, that those of us who've done it know how hard it is to install this stuff. And you miss a library here, you miss something here, and nothing works. Everything is distilled down to this one line. And it's amazing. It's literally like, what, 3 words.
Kind of like hardening built into it.
So interestingly, the hardening is all coming from not the application itself. So, that WordPress bubble that we installed, for argument's sake, let's say it's an incredibly leaky piece of software. It's terrible. It's got no security whatsoever. The hardening will come from the fact that it is installed inside of micro-K8s and it is protected there, right? So in a sense, regardless of the quality assurance of your application, you're getting a lot of security from the underlying platform where it is, segmenting things out in containers and pods and so on and so forth. And so even if you have some, terrible quality software, at least you know that that's not going to mess with everything else in your system. It'll kind of stay in its space. So, it's the bad apple, it will remain the bad apple, but it will not influence the other apples to become bad apples, right? Okay, so we got this thing done. Now, interestingly, if you want, you can just say Juju status, and it'll tell you, oops, STATUS, that is doing something in the back. So it'll come up and pull that up, and it's now starting to get slow. There we go. So what we see on the screen is there is our model with a controller, right there, and it's running on micro-K8s cloud. There is our applications. So there's the database, It has an IP address and it says it's currently installing the agent. There is a WordPress application, which also has an IP address and is installing. But again, below here, we have something called a unit. So unit has to do with the actual unit. Like you can have one unit, you can have 4 units of something to scale up and scale down. So I can keep running this command, or I can say, okay, let me give it like 2 minutes and then go back and run the command again. What I want is that I want everything to be installed. I don't want anything to be installing or initializing before I go to the next step. So at this point, I usually give it a few minutes, go get a drink of water or something, let it sort of do its thing. Plus I'm running on this VM, so it's going to be a little slow. So fingers crossed, I hope we run through the demo and not crash and burn on this laptop. See, oh, low disk space. I'm getting warnings. Okay, we'll ignore it. I think we should be okay. Okay, so it's still initializing. In fact, while it is doing this, what I'll do is I'll pull up the dashboard so you can actually see what Kubernetes looks like in a browser. So there's a dashboard running in a browser. So if I do microkates dot, what was it? Dashboard? Proxy, yeah. So we'll run this command here. So basically this will give us a link to open up a browser and see what this looks like. So, and I'm hoping nothing will crash. So it says checking if dashboard is running. Okay. And then it'll give me a token, because security wise, you don't want anybody to just look at the dashboard. So it'll give me a token. That's my token. That long thingamajig there is my token. So I got to copy this, right? So actually, let me first open this link. So if I go there and say open link, it should fire up Firefox. And it's kind of slow as molasses right now, but it should fire up Firefox and then pull up the dashboard and then ask for the token. So we'll wait and see what it does. And I can hear the fan on my laptop. It's spinning away at this point. Aha, we have success. We have Firefox. So, and there we go. And because this is running locally on the laptop, it'll say, oh, warning this, and you say advanced. And throw caution to the wind, and where is it? My cursor is gone, missing. Okay, so it says it's not valid. Oops. And we will say, accept the risk and continue, right? Because there's no certificate for this. So it's complaining. We'll say accept the risk there. And at this point, it'll ask me for that token. Well, if I had 64 gigs of RAM, this would be a breeze. Okay, so it asks for a token. We'll go back here. We'll say we want the token. So this long string of things, right? I'll grab this, copy it, and then we want to go to our Firefox in here and say, oh, here's my token, and sign in. So this authorizes us to sign in. We'll say save. And here is our dashboard. There we go. So there's Kubernetes dashboard. So this looks like any Kubernetes dashboard, not micro-K8s only. So regardless of where you run Kubernetes, this is the dashboard you would see. And here is the things running, and we want WordPress controller because that's what we set up, right? And here's WordPress controller, and it'll pull up deployments, pods, replica sets. It'll tell you what's running. It gives us, you can see here, CPU usage, memory usage. Memory usage is maxed out, right? And from here, you can basically get all the stats you need for Kubernetes, which is running right now. So what are we running right now? We are running Kubernetes. Inside of Kubernetes, we're running WordPress, MySQL. We still haven't connected the two as yet. And we are running all of that inside of a VirtualBox VM. In your case, Kevin, because you're running it natively on that laptop, and I could run it natively here as well, but for the purpose of this workshop, I used VirtualBox so that if a student has Windows or Mac, they can kind of follow the same thing, right? So obviously, if I wasn't running a VM and running it natively, it wouldn't consume so many resources. So this is running here. Now, if we go back to what we were doing here, we would, I can say Control-C to sort of kill this. We can go back and look at our status once more to see if everything is installed. And then basically connect. So it says agent lost. So something happened there. I think I'm just running out of memory. So I do have some more steps that would work after this, which I think because of the Zoom running in the back is not doing this, but this step here where it says Juju relate, that command basically connects the two. And then finally, you can use this command to get your admin password for WordPress and log into WordPress and then be able to set up WordPress from there. It'll basically be running inside. So, and then that's our dashboard that we just ran. So you saw the dashboard. So these are the ones. And then now comes to the question that Chris had in terms of scaling up, right? So for the purposes of this workshop, we'll say that, we have successfully run micro-K8s, which we have. And we ran WordPress and MySQL on it. So scaling up. If I had this laptop connected to, let's say, a switch or a router, Ethernet router, right? And then I plugged in another laptop or a Raspberry Pi or something else, and we installed micro-K8s on it. By using this one command, micro-K8s add node, it basically allows us to add other computers as nodes. So if I run this command, it basically gives me a key, and I copy paste that key into that other machine, and then that machine will contact this laptop and become a node. And the same thing can happen for a third and a fourth, and you can also automate this, right? So the moment you hit 3, which is this laptop and let's say 2 Raspberry Pis, it would be considered high availability, which means that it thinks that if there are 3 machines, if one starts to fail, I can switch over to the other. And from there on, the networking that is managed by Kubernetes uses something called Calico. It'll do all the balancing and all of that stuff that, it would be a nightmare to do, honestly, if we had to do it by hand. So yeah, you could have 8 Raspberry Pis and you could build a mini cluster. You could have, I see those ads on Craigslist where they're selling laptops, used laptops for like $100 or something, right? You can go buy a whole bunch of old laptops and you wipe the thing and image it, and you would have a laptop cluster in a mini rack, right? You can do all kinds of interesting things with it because then you have that high availability thing. And in terms of working with it, you're still working with this one main machine, right? The installation, everything is happening like I just did. It figures out how to do this. Now, there is a possibility of using what's called a worker flag, in which not everything is load balanced, only certain things are. But that's sort of a thing in terms of architecture. So you could arguably do this. So that's something I want to do next after, now that this workshop is happening and we kind of see how this works, the next step is to do this, which is scale up. So I have a few Raspberry Pis at home. I know Chris has a stack up here. So one of the projects could be, we can go grab a bunch of those and set up in a network at some point. And, you set it up here, and then you start to add those.
We could actually set up one of the rooms there.
Yeah, one of these rooms here, we could have a thing and then set up the project. So this is something that I have my eyes on, and I'm in the process of getting this. So what you see here is each green board here is actually a Raspberry Pi, but this is called the compute module, CM. And it's not like the regular Raspberry Pi where it's got ports and all that. It's basically just a board with a couple of strip connectors at the bottom. So it plugs into this main mini ITX board, and you can plug up to 6 of those, right? So I have 4 of these, I'm getting 2 more. So I'll have 6 compute modules. And then I'm getting this board, the Super 6C. This would be 6 Raspberry Pis. And when you plug that into the switch, it'll show up here as 6 nodes. And you can basically add those 6 nodes to your laptop, and you have a mini cluster there. So there's some documentation, there's a video of running a cluster using Ceph. Ceph is a storage balancing system. And so there are examples of that. You can do Ceph. So I have a link here if you want to follow examples. You can build this also. So think of it as RAID, but not using RAID for storage across multiple servers. But the concept is similar. It's like the hard drive in each server basically becomes a part of your storage. And then there is Spark. If you do anything on Apache Spark, for instance, for a lot of data analysis type stuff, you can set up that on there as well. So there are a couple of examples. And then, there's a whole list of other things we can find online. But I found this one, and then Kevin's examples are for a software called Mattermost, which is so that's Mattermost, and it is a collaboration. So sort of like, it's like Slack, right? It's similar to Slack, but you can run it on your own infrastructure. Like you can run it within the company and not have your traffic and all the conversations go out to Slack. In fact, at this point, this is becoming increasingly critical because for so many of these large language model systems, they need text data. So guess what? All the stuff that is on your chat network would be excellent for this stuff, right? Now nobody wants to give up their text data to anybody. So that means you have to run this stuff in-house. So Mattermost is another example that Kevin has documentation for to set it up. And then there is Ceph. So I've tried Ceph, this one here that I was showing you for storage. I haven't tried this one yet. I haven't tried Spark, but I've tried Ceph, and Ceph works quite well. So some examples there. And then, so hopefully sort of bringing it back to where we began, those terms on that poster should no longer be buzzwords. At least you should have a sense of what this means, right? So now I would say, putting on my teacher hat, not my geek hat, you'll have to do this a few times. You folks in the room and those who will be watching this later, you have to try to do this a few times. You'll get stuck, stuff will break, you delete it, you start again. I'm in the not the science building, the creative arts building. I used to be in the science building. 254, come see me if you need help. And other people who would be interested in this, you can run another one, as a fun activity. We'll be here for a bit, so we'll switch gears. I'll stop the recording and then we'll see if we can set up on your laptop or anybody else's. But hopefully you found it useful. Try it. I mean, the worst that will happen is your computer is going to shut down, and then you reboot and you come back, right? Okay. Questions? We good? Okay, so let me stop the recording so that we have this available for everybody. And then we'll switch gears to, okay, so I'll stop.